I have a question. Then what is the 13, 14, 17, 24, and
This
then 19
is
something?
this is where these strings live in memory.
So how about the 7, like the 5788?
That's where this array of tokens lives in memory. This is how pointers work.
But then I get mem though, like if I have like a token, like if I have the string hello world 2020 and then I pass in, I will take like you know like the hello and get the memory 5, like memory 6 for it, because like I would use get mem to get the memory address for
Right.
hello.
But that's a new place in memory. You need to get, so you're going to say I have 3 tokens. So you're going to ask get mem to give me enough memory in a row to give me 3 buckets that can each hold a memory address. This guy, and this guy. And each
Okay.
one, and then what you're going to do is you're going to say, okay, now I need enough memory to hold this string right here. Hello. And it's so get mem is going to give you this 1314 value right here. And that's what you're going to put at bucket 0 here, because this guy points there. Then you're going to ask, for enough memory to hold world. You're going to ask get mem for that, and it's going to return, maybe, you know, consider that a whole bunch of other stuff has already happened. So it doesn't give you a memory address that's near this guy. It just gives you this new memory address, 1724. You know, where you have enough space in a row to hold the W, the O, the R, the L, the D. So you're going to store that memory address here because this guy points to the beginning of world. Similarly, you're going to say, okay, I have the string 2020, so you're going to ask for enough memory. You're going to ask get mem for 4 bytes. So it gave you 1908. So this guy points to this other place in memory. So this is an array, this is an array, this is an array, and this is an array. This
So then,
array
okay.
has 3 buckets containing 3 memory addresses. Each of those memory address points to another array in memory where those strings actually live.
So then, okay, so then I have a question. So then, for example, if I have a token and then I use the get mem for that token to get like 3 executive memory address, so that means like continuous one. So that means like, for example, that would be 88, 89, 90. So that's like where is like the 3 memory address that is given to the token. But then
Right,
like
this is
am
your
I gonna
array.
find like the hello like address again? So like, am I doing a double get mem? So then it will end up to be like
you're
88,
going to ask,
89, 90, 91, 92, 93.
well, probably yes, but your second get mem, so you'll say get mem once for this guy. So this is your first get mem to get you 3 by 4 bytes. So that, because this is 4 bytes, this is a memory address, this is a memory address, this is a memory address. So we have 4 bytes here, right? So we have 3 by 4. Because I need 3 buckets of contiguous memory, each capable of holding 32 bits or 4 bytes. That's what you ask get mem for first. Okay, does that part make sense? Just that part. That gets you memory for this array right here. Forget about what we're going to do with that array first. Just, you're going to call get mem one time and ask for enough memory to hold 3 of values that have 4 bytes in them.
So then that would be 32 bits.
Yeah, 32 bits. 4 bytes is 32 bits.
Okay.
So this will actually be 12 bytes total.
Okay.
Because this is a memory address, this is 32 bits, this is 32 bits, this is 32 bits.
Okay.
Because we've decided that we're going to have 32-bit memory addresses.
3 times 4.
I need 3 buckets, each of 4 bytes in size.
Okay, so then if
Contiguous memory.
I have a question. So then, for example, if I say, let's say I got tokens and then I say get mem 3 times 4, it will give me a memory address, but it's not going to give me like 3 memory address, but like only one
Right. It
memory
gets you
address, which is the starting point.
this guy, the base address. Correct. That'll get you the base address. And then you know that bucket 0 of that guy is here. Bucket 1 adds to it 4 bytes. Bucket 2 adds to it 4 bytes.
Okay.
So this is 0 times 4 bytes, 1 times 4 bytes, 2 times 4 bytes off the base address. Does that make sense?
So, okay, so then if I have a base address, then in order for me to find the next address, I will take the base times 1.
Well, the base
No,
plus
plus
1
4.
times the size of the value that lives there.
What does that mean?
Well, the size of values we asked for here are 4-byte values or 32-bit values.
Okay.
So this is bucket 0, so that's the base address plus 0 times the size of the thing. So 0 times 4 bytes is 0.
Okay.
Bucket 1 will be at the base address plus 1 times size
4.
of, so 4. So it's 1 times 4, so that's 4. So this address plus 4 will get me to 8C. Bucket 2 will be 2 times size of address, so it's plus 8. This number plus 8 gets me to bucket 2.
Okay.
This is just a normal array, a contiguous array that holds stuff. The difference here is the stuff that this guy is holding are memory addresses. I haven't put them in there yet. Well, you see me, I've drawn them at this point, but I haven't actually put memory addresses in there. So now I'm going to go ahead and I'm going to say get mem, give me enough memory to hold HELLO. And
Okay.
let's just say that gives me the base address 1314.
Okay.
So that's going to be 1314, 1315, 1316, 1317, 1318.
Okay.
And I'm going to store that at bucket 0 in this array up here. So that guy points to where this string lives in memory. Realistically, this guy is probably going to be immediately following this array because that's what getMem is likely going to return for us, right?
Okay.
Because you're the only one using getMem. But I drew it like, hey, you're one of 50 programs running on the computer, so we don't know where this guy lives in memory, but he'll live somewhere in memory, and I'm going to keep track of where he is right here. This guy is going to be a pointer to the very first token I found, which I'm going to store in memory here. This guy will be a pointer to the next token I found, which I'll store in memory here. This guy will be a pointer to the next token I found, which I'll store in memory over here.
Okay, I have a question. So for example, if you say that, let's find get mem to take the hello. So for example, that would be 91 in my case, right? So 88, 89, 90. And then if I talk about get mem again, would that be 91 or no?
Probably it'll be 91 because of how getMem works, and you happen to know that you're the only one calling getMem.
Hey, I don't think it's 91 though, because like if it's a 90 and then I plus 4, so would that be like
But
my
it wouldn't be
getMem would
plus.
start?
It wouldn't be plus 4. This is only 1 byte. We're using ASCII for characters. This is
No,
1
like
byte, 1 byte.
hello.
Well, it'll be 91, 92, 93, 94, 95, and then we'll have that \0 here too. So that's 96.
I don't think that's a correct statement though, because basically you're telling me that you do take 3 times 4.
No,
So
that's
then the
just for this
memory.
guy. That's just for this guy. 3
I
times
know,
4.
but then here, let me explain a little bit why I think it's kind of weird, because like if you take that and let's say you asking for 12 memory address in a row, correct or no?
No, that's not what you're doing, because
What?
H is not a memory address. H is a character. So for this guy, this is 1, 2, 3, 4, 5, and then I need a 6th for the \0. So this guy is, I need 6 buckets by 1 byte each. This is a
So
byte,
would that
byte,
mean
byte,
6?
byte, byte.
Yeah, so would that mean 6 memory address then?
No, 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 no. 6 bytes.
What?
Character, 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 character.
But
This
you
is a,
say
now listen, this is a memory address. This is a memory address. This is a memory address. So each of these, even though getMem gives me bytes, this is 4 bytes right here. This is 4 bytes. This is 4 bytes. This is 4 bytes. And that's what this homework does. So this homework subdivides this into 4 slices. So the 4 in this case, even though this is a crazy memory address, that really isn't. So I'd have the 0100, then I'd have 0001, then I'd have 0011, then I'd have 0001. That would be the 32 bits that lived in these 4 bytes. So the reality is this is actually a 12 bucket byte array where each grouping of 4 buckets has meaning for a single memory address.
Okay, I have a question real quick. So we're doing 1 byte resolution, right?
Correct.
Okay, so for example, you know, I'm not talking about hello world or anything. I'm just talking about the arrays in general. So now, for example, if my memory is starting at 80, like my whole empty memory is starting at 88,
Yep.
and then you get like 12 bucket for it. So then, like, for example, like the first 4 memory address is for like the first bucket of 0, and then the next 4, and then the next 4 is for 2. So basically saying that if I'm starting at 88 and then I plus 4, that will be like 92 is my next number 1, and then I plus
No.
4. No,
Because 88, no, so 88, this guy is 88, 89, 8A, and 8B. That's what lives here.
hang on, what did you say again? Can you say
80,
it again?
88,
Okay,
89,
okay.
8A, 8B. Those are the 4 bytes that are inside this box. To
What
give
is
me
A and HB?
8A, 8B. 8C lives here. These are hexadecimal.
Oh.
So counting in hexadecimal, 88, 89, 8A, because 9 plus 1 is 10, 10 is an A, and then 8B. 10 plus 1 is 11, 11 is a B. So that's what lives here, those 4 bytes. Then 8C lives here. 8D, 8E, 8F. Those are the 4 that live here. And then 90, 91, 92, 93 live here.
So then if I'm starting a new address, it will be 94.
Correct. It'll be 94.
I see. So then.
And
so
this
then,
would be 94, 95, 96, 97, 98, 99.
Okay, so then my first address for hello would be at 94.
Correct.
And then my second address for the world would be at 99.
This was 99, so this is 9A. 9B, 9C, 9D, 9E, 9F would be the \0.
I have a question. How do you how do you like, I don't know how you count it, because like I feel like I kind of misunderstanding in like, because if I count it I would be like 88, 89, 90, and then it makes me go into like confusion. So like,
right, these are not
exactly,
because these are not decimal numbers. These are hexadecimal numbers.
So how should I count a hexadecimal number?
Well, okay, so you would say 88, 89, 810, 811. But 10s and 11s are not represented as 10 and 11. They're represented as A and B. So we go through, we have 0 through 9, then A through F. So 88, 89,
and
8A, 8B, 8C, D, E, F, and then 90, 91, 92, 93, 94, 95, 96, 97, 98, 99 is this \0.
And then
9.
and then 99, and then 9A.
9A, 9B,
9B, 9C, and
B,
then D, E,
E,
F.
and then F would be the \0 here.
Okay.
And now we're at 100. So we actually will have so now the 7 becomes an 8. So we're at
Okay.
800. So this is 800, 801, 802, 803, 804 is the \0.
So then as long as we are at 100, then we plus 1 to the third position?
Yeah, because so this is 788, 789, 78A, 78B, 78C, or 78B, 78C, 78D, 78E, 78F, 790, 91, 92, 93, 794, 95, 96, 97, 98, 99. Then now it is 800, 801, 802, 803, 804, 805, 806, 7, 8, 9, and 80A.
And then it will go from A through F, and then it will turn out to be 11.
A
Oh,
through F.
No, it will go from A through F, and then it will turn out to be 7810, correct?
Yeah, 810. Not, yeah, so it'll be 810, because we were only in the 7s up here.
Okay.
Then we went to the 8s down here. So this was 8, wherever it was. 8. I think this was 800. 801, blah, 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 blah. Then it would be 810, 812, 81F, then 820, 8 blah, blah, 82F, 830 through F, 840 through F. Once we got to 890 through F, then we would have a 900. So this is hexadecimal base 16 counting.
Okay. Okay, I will try to fix my code that way.
All right, so
That's understandable.
This makes more sense?
Yeah, will you post the recording somewhere or?
I'll sell it to you.
No, I'm
So watch
here.
this. Watch this. My marker goes back. So if I throw my marker there, look, it just goes back. Isn't that cool? So how was this? Was this a pretty good way of explaining stuff? Like, was this better or worse than using Keynote?
I feel like Keynote is like, I mean, you know, based on this is such like a simple like question, so like this is not bad, but like if you're talking about like a big picture, like a big idea thing, and you're using this, and that's quite a bit.
Because I was able to point to things, though, is this better, do you think? Or is it at least equivalent?
Yeah, it's I would say it's equivalent to Keynote.
And see, I could throw this. I can go like that. Well, I don't know if that really helped that much. So I have this guy. I don't know what this is for. So that's also part of your homework now. Just tell me what this guy is for.
I don't know.
All right. So that gets you what you need?
Yeah, if you can send me that video in case like I'm getting stuck again.
All right.
Thank you. Appreciate it.
Yep. Have a good one.
You too.